Hello everyone, we're still waiting, so no panicking. um, Hello Royaloff, hello Hellhunter, hello Aurora, hello Mikhail. Let me post once again. Okay. All right. I think we can start. So before we start, I'll mention that I thought of merging some lessons that I mentioned before, and I noticed that I forgot a few topics in the initial program that we had announced. So there will be a bit more stuff, but there won't be more lessons than there is already. I'll just try to merge contact. So for this lesson, before we had struct as a separate lesson, but I think it suits well with this lesson, which is with lesson of ref in and out. All those in isolation are not big topics, so they can easily be merged. So today we'll talk about struct. We'll compare struct versus class. We'll discuss when struct should be used and when should it not. We'll talk about ref in and out, modifiers, keywords for parameters. We'll talk about discard operator, and we will talk about when should you actually use ref in and out and when you should not. So let's get to it. We'll start from a struct. When somebody talks about structs, you should think about value objects, about something that is still a primitive, almost, except that, well, something that has a single value, that represents a single value, that doesn't make sense changing a part of it because it would get a whole different meaning. So a value object, something that refers to a single value made of many pieces. A few pieces or many pieces, doesn't matter. For example, in programming, we have this problem called primitive obsession. When programmers define everything as a primitive, they have flat classes with a bunch of primitive variables, fields, members. For example, a person who has a phone number, country, area code, and then you start mixing. Is the country for the phone? Is the area code for the person, or is it also for the phone? Like, what is a phone number really? Is it just a string or is it something more? You start mixing yourself. Or for example, if you have a location, you have X and Y. Is it a primitive? Should it be a class? Should it be something else? You start confusing yourself with such things. Or for example, when you pass a parameter and you actually pass 10 parameters, and in reality those 10 parameters are just 3 bigger objects instead of 10 parameters, because it's really bizarre seeing a massive long method declaration. It shouldn't happen. And solution to those problems are value objects or structs. So a single value in a shape of an object is a value object, is a struct. So here's an example of the problem I talked. We have a person, and a person has a name, number 1, area code, country 1, and then he has number 2, area code 2, and country 2. And it really doesn't make sense, especially since you have repeated pieces of data. And in this case, especially, it makes sense to split number 1, area code 1, and country 1 into something of its own. So we split it to not a class, but a struct, because a phone number is just one value. It doesn't make it doesn't make sense for it to change. Like if you get a new phone number, then it will have its own area code and country, and it doesn't make sense to change country without changing a number. So if you change a part of a phone, the whole phone number changes. So value objects don't allow changes of their member. They're supposed to be immutable, because changes for such objects would not make sense. So if you have such a scenario where changes in object don't make sense, and it's a small one, it's probably a struct, a value object. So this is a scenario. So now when we look at the person class, we can see that the person has 2 phone numbers. And here is one tiny refactoring on top of this. I refactored person a bit further by splitting phone number to be just contact info. So now we know that person has a name and contact info. And now we can change contact info without changing person class. So we separated that piece out, as it is slightly more clear what number 1 and number 2 actually refers to. It's contact info. Maybe it's work number and then home number. Doesn't matter much, but that's one way to refactor it. Main point, have it a struct to represent a few values that are tightly related, that are a part of the same concept, that don't change, that are small, that make an object which is not too big, which is small, when combining those values. When you create a struct, it's also important to mention that everything that you have in fields must be initialized in Constructor, because it's immutable. You can only initialize it, you can only assign it when you initialize it. So there is no other way of setting value for a struct, only from Constructor. And one interesting part about struct is that normally we use properties, but for struct we are allowed to use fields as well, because struct in its essence is supposed to be a simple data structure. And Aurora asked if fields for struct are uppercase, and the answer is no. It's the same convention as for a class. It's simply public, and therefore it's Pascal case. Whatever is public or protected should be Pascal cased. And fields are usually private, and therefore they're not Pascal cased. They're rather prefixed with underscore and then camel cased. Another example for value object is a point. It's a really good example. So a point, imagine a matrix of pixels, and pixels are not floating point numbers. They're just indexed dots on some matrix, and they can either exist or not and have a color. And a point is such pixel. So a point is really a value object as well, because it's small, it just has an x and y, and it supports calculating distance. So for this particular data structure, we have a point, and from one point we can take another point to calculate the distance between those 2 points. Very simple, trivial, and useful. When I was learning about structs, I always had this misconception. So point, struct I thought is very simple, almost a primitive, just encapsulating a few values, and I thought that it shouldn't encapsulate logic, like that something externally should calculate distance for a point or do some other stuff, but externally, like a strict separation between logic and data for structs. But that is not true. The same principles apply. So the same principle that if an object can manage its own state without some service, without calling some service, then it should. So I can still accept some object which serves as an input, but I shouldn't call some service from within a struct. It's too complex. So yeah. Another example of a struct would be datetime, but about it we'll talk during live coding. So if you compare struct versus a class, it's basically comparison of value type versus reference type. So structs are passed by value. That means when you pass a struct, you copy all the values. So even if you could change a struct, those changes would not persist. And class is passed by reference. That means that changing something, some member in a class would persist those changes outside it. But copying values is faster than working with references, because you don't need to do lookups for finding the according appropriate values for those references where they point. But the downside of structs is that they take more memory because they get copied. Erlington said that int is a struct, but that's not true. Int is a value object. Struct is a value object. I can quickly show you what I mean by value object or by struct. So if you go to C#, you'll see a structure type is a value type. And then if you click on a value type, you'll see that there is a whole bunch of value types. Structure type, enumeration type. Integral numeric value types. Yes. So I think all those are primitives and all those are value types, not structs. Yes. So you can see that it is not a struct, it's a value type. And if I go to a struct, so here's the inheritance tree. For example, a primitive type is a value type, is an object. And if I look at struct, it's a value type basically. So both int and struct derives from the same thing, but ints aren't structs. That's what I mean. They're slightly different. They're special because I don't need to do new int for those primitives in order to instantiate them. I can just say int a is 5 instead of creating a new int. So that's slightly different. You cannot say that they are the same. Int is not a struct. Struct and int are both value types. And as Erlington mentioned, it's important to note and to make the intention clear that structs are read-only. So there is a read-only keyword made for a struct, which would explicitly require for every member of a struct to be read-only. And you can achieve read-only for a struct either through a getter, a getter-only property, or a read-only field. And in this case, and in my own preference, I choose read-only to emphasize on the simplicity that struct has. Right. One more thing to note about struct. Struct should not be assigned to object because that would do some operation called boxing, and you don't want that. So don't, when you assign structs, always assign them as is and not to some abstracted version of struct. Don't assign structs to objects because it's bad for performance. Just assign them to whatever type there is. So for example, don't say object phone is new phone number, but just say phone number, phone is new phone number. We'll talk about this operation called boxing in particular later. Now, the metal fees asked, so in best practice, a struct is basically a read-only group of primitive variables, and the answer is yes. Essentially, it's a logical group of primitive variables, but a small group. If you open C# docs, MSDN, you'll see that a struct should not be bigger than 16 bits. And 16 bits or bytes? Let me check. Probably bytes. Struct recommendation. And this basically means it shouldn't have more than struct versus class. Yeah, byte seems more accurate. Class C#. And this means basically that it shouldn't have more than a few fields. 3, 4, 5, probably not more than 5 fields in a struct is what you should go for. Here it is. Yes, bytes. Makes sense. So times 4. So 6. Or times 8. Was it 4 or 8 byte? 8. 4. Okay. 4 ints. So for a string, I'm not sure. But my own way to go for structs is to just stick to a few fields, not more than 5. 5 is probably too many. 4 is on the edge, on the verge. I'd stick to 3 or so. How big is string? String C#. Bits size. I'm not sure how big is string saved in memory. It probably varies a lot. It would depend on characters, that's true. So I guess it really depends on the size of string for structs. And in this case, for a phone number, it wouldn't be more than 12 probably symbols. For area code, not more than 3 symbols, and for country, not more than 30 or so symbols. So it's probably legit for such struct size like this. Let's continue. So now let's move on. Do you guys have any more questions about struct? Michael asked, string 4-byte address length up to 2 billion bytes. Okay. I'm really bad with those low-level things because it's really normally not a concern of mine. Well, Erlington said that in general you can say use classes whenever possible and do not care that much about structs, at least at the start of programming. I would agree, but we're trying to acquire some tastes for quality code, and it's not hard to apply the design for a string. Just if you have 3 or less fields, use a struct. If it won't change and you have 3 or less fields, use a struct over a class. That's my go-to. If it's not a service, if it's 3 or less fields, if it won't change, then use a struct. It's a simple rule. It is more rare to have a use of such rule than for a class, for example. Class, you just use it almost everywhere, but it's just nicer and makes the intention clearer. Also is slightly better for performance, among other things. So struct is nice. Now let's continue. Ref in and out. A few modifiers for parameters. In C#, when you pass everything, you actually work with copies of stuff. So when you pass a class as a function argument, you actually work with a copy of a reference to that class, to that object. If you pass a number to a function, you work with a copy of that number. You never work with the original of what was passed. Never, ever. Always working with copies. Reference basically means that you pass, a modifier means that you pass something by reference. And it can be applied both for value types and reference types. For value types, it means that you pass a reference and then you work with a copy of a reference. So if you change a value for the thing that you passed within the method, it will remain. The changes will persist. that's the use of reference, to persist the changes when passing it around in a function for a value type. And you normally want to use that when something that would be copied instead is inefficient to copy. It's too big to be copied. And therefore you want to pass it by reference so that you don't waste memory and spare instead some CPU time for looking up those values by reference instead of by copies of values. So in this example, you see we have ref test method, and we pass int number by reference. And in the method, we say number is 5. So outside the number is 5 will persist. So in the example, in the main function, we can see that initially our number was 1. And then for normal function, we said number is 5 in the test function. And it didn't change after we called writeLine, because when we passed the number for the first time, its value was copied over. And we changed a copy of a variable, so it didn't affect the original value. But in ref test, we passed number by reference. So we copied a reference, and we worked with a copy to a reference, which still points to the same value, to the same variable. And so we changed the variable. And so now the reference points to a different value of a variable. But the value itself now persists. It's changed because the reference points, the point at which reference pointed remained, persisted. It just got copied over. A bit confusing to explain. Do you have any questions about ref? Because I might confuse you with the way I explained. All right. So in is very much like ref. You also pass stuff by reference within modifier. But the main difference is that in modifier doesn't let you modify whatever you passed in a method. And you might ask yourself, why would I use in if I can use ref? And the answer is, modifying something is slightly more expensive than just reading. So for performance purposes, for the same reason why would you pass anything by ref, it's slightly it costs slightly less memory. So for performance reasons, it makes sense to pass something by reference. So if you want to pass something by reference, just to pass it, not copy over, then you would use in modifier. In modifier is actually very new and often considered exotic because it's purely for performance and in super rare cases. And I personally have never used it in my career. So you don't really need to understand how it's used. You just need to be aware of. One more reason why will you need to use in over ref, or why would you need to care less about in over ref? Because when you call something that is within modifier, you don't need to pass in modifier when calling a method which is declared within modifier. So for example, if I have method in test, I set in int number, which means I pass number by reference. But when I call in test, I don't need to say in number. I just say number, and it will just pass that number 5 by reference. but I won't change it, so there won't be much difference. And probably in this case, it will be even slower, in fact. For out, you guys are familiar already because you had to do parsing, converting string to a number and doing all sorts of other transformations for related to string to other types. So try parse is a way of returning a result of operation, or whether or not it was successful, and also returning the result, another result, which is what was actually parsed. So for example, if I try parse from int, that means I return true, or true if I actually parse the number, and I return also a number that was parsed, or default number 0, or something else if it was actually a number. So that's the use of out. And when you call out, when you declare a method with out, or when you call out, you must provide the out keyword, unlike the in keyword. And there is an interesting thing called a discard operator. What if you just needed to check if a number is, if a string is a number, nothing else, you don't really need to know the result of a parse operation, which is a number. You just need to check if it was successful or not. And if you want to do that, you can use a discard operator, which basically says, all I wanted is the result of try parse operation. I just want to know if it succeeded or not. I don't care about the output, about the number that was parsed. I just want to know if in the first place it was a number or not. You can use discard operator for that, because you wouldn't need to waste some variable explicitly storing value in it. You can just say, I don't need that value. And you use discard operator by simply replacing variable that you would put next to out with underscore. And that's out operator. So in this example, we parse input from console. We get input from console, we read input from console, and then we check if input was number. Since we don't need to know what number it was, just if it was a number or not, we use out operator, as you can see in the crossed section of code. And now you might ask yourself, when should you use ref, out, or in? And the answer is almost never. Avoid using those three as much as you can. And logically, I never had the use of using ref and in. Only when the framework requires me. For example, if a method already has methods declared, defined with ref keyword, sure, use it, pass it. Don't be afraid of that. The guys who made framework and those methods really knew what they were doing, so that is fine. But if you are making your own methods, just avoid using those three keywords. However, out is an exception. There is one very good case for out, and that is when you have the try parse pattern. So you can make your own try parse for parsing something from a string that is your own, for example, a point. So here you can see that we parse a point from a string. So we care about if it's a point defined in that string, and we want to get the results of the parse. And here you can see the implementation. So it's quite simple. At the start, we say that the point has default value. Default is a keyword that says that it's default value. It could simply mean null. Actually, null won't work because it's a point, so it has no reference. So null doesn't work. You must create a new point with 0, 0, or you can simply say default, which does the same. So I first check if string is null or empty. That means that there is nothing to parse, so it's not a point, so I just terminate. And then I say if the string is comma separated, then I split it, and if it's two parts, if the comma separated parts are not two, then I also say that I need x and y in the string. So if it's not two parts, I also terminate. And then I say if x and y are both numbers, if x and y are not numbers, then I also terminate. And if they were numbers, I create a new point. Also, one interesting thing, here is a tiny mistake. Can anyone see the mistake that I made in this code? There is one mistake. You see, y is for some reason underscored. Does anyone know why? It's a really tricky thing. So how would you fix it, Rasho? That's true. Yes, you would use one end, because single end would mean that both sides would be evaluated. It wouldn't short circuit. Yep, well done. All right, so don't use ref or in by yourself. I don't see any reasons when. Use out when you do try parse pattern. That's a good case. And you just witnessed the language features of C# and that it's pretty cool having a distinction between value objects and just normal objects, something that can be passed by reference and by value, and about discard operator, out operator, and there's many more things that are to come that you'll witness in the next lesson as well. The next few lessons will be focused on C# language features, on those very simple yet very convenient and useful features that you will be able to apply immediately. So next lesson, we'll talk about more syntactic sugar like ternary operator, like conditional operator, and others. Yeah. So guys, do you have any questions? Again, I would love everyone to write one thing they think they understood well and one thing they would like to understand better. Like, what would you like to know better from the lesson, and what can you write about what you learned this course? One sentence what you learned in this lesson, and one sentence that you would like to learn better. Catgirl Aurora, I will not teach more about in because it's too exotic. It's too exotic to be talked in detail. If you want to learn more about it, there is a nice discussion. C#. There is this discussion. Struct. When should you use in? There was this one. Yes, this post. So for those who want to learn about in modifier more, I recommend reading the Stack Overflow post. But I'm not in a position to talk about this in detail. Now let's do some live coding. I'll delete this. Okay. So for the in, I'll just demo in specifically so that you can see how it works. So we have in demo. So we have our in demo, our in test, and in demo. So you have a method where you pass number with in modifier. And if I do something like this, you can see it says cannot assign variable in because it is a read-only variable. So in modifier will pass number by value, by reference. Sorry, it will pass number by reference, but it will not let you assign it because this variable becomes read-only. If I pass it by reference, it will work. So if I pass by in and try to build, it won't work. If I just print it, it works. And when I call it, I don't need to say in here. It's not needed. So that is the in demo. Now let's do the ref demo. Yeah, it's, well, Aurora thinks that performance is a great thing and that in might save it. And that is true. It probably would save performance when you're passing big value objects. But here's the thing. You're not supposed to be having value objects in the first place. Big ones. Because they're supposed to represent a single value. And a single value is just a collection of a few things. Keep it small. Keep value objects small. And if they're big, and if you pass them using in modifier, well, that's just a workaround around another problem. So it's not really a solution. So let's try this. So we have ref. Let's debug this. Yes, the lessons are saved. There is a YouTube channel for the lessons. I'll link in the chat after the lesson. Just remind me if I forget. So here's the ref demo. We have a ref test method, which basically sets whatever is passed to 5. We pass a value by reference, and therefore, if we change a value passed by reference, the changes will persist. First, we have a test method, which simply passes a number as is. So it passes a value by value, and like we said, it makes a copy of it. So here I set number to 1. I went to this method, it's still 1. If I print, it prints 1. Now in my ref test, I go in, I have a number, it's 1. Here I have a number, it's 5 now. Now both are 5, and both are this and this are two different copies of reference, but they both point to the same variable, number. So I set a value of that variable to 5, and so both references, original and copy of reference, point to the same variable, 5, number. And therefore, outside, I also see a change, 5. And now if I print it, you can see it's 5. So that's the ref demo. I think one thing that is really interesting about ref, what happens if you pass a reference type by reference? And what do you guys want to make any guesses? What happens if I create, let's say, a person? So I create a person using a reference type. So what happens if I create a method like this? So I have ref person. That's perfectly valid. So what do you guys think will happen if I do something like, actually let's make ref test 2, ref test person, private static void. So we have two very similar methods. In here we have new person, and we say that their name is John. And here we have a person, and we say that their name is also John. JO Striker asked what happens if you call a constructor which does nothing. So every class has a default constructor if no constructor is defined explicitly. Sorry, so what was the question? Oh, okay. I asked what will happen specifically to the person. So if I do the test and say, so we have this person whose name is Tawny, right? And we say that we test person and we test person with ref person person, and we print its name. We print its name. So what do you think, what will be the person's name in this case? Two times John, you think? Okay, any other guesses? Two times Tony? Okay, any other guesses? Okay. So it's quite interesting. This is one of the unexpected behaviors. Remember how things work. I forgot to put different demo. Let's go. So we created a person who has a name Tawny, okay? In the first test method, we create a new person and assign its name. But remember, what happens when we pass an object by an object? Object is a reference type. And so when we change something in an object, the changes persist. But this, and when we pass an object, which is a reference type, we actually copy over its reference. What happened here is that we created a new reference to an object. So this and this now points to different things than originally. Therefore, if we print a name now, it will be still Tawny, because within the method we created a new object which created a new reference which points to a different thing. Now, if we pass a reference object by reference, that means that we pass a reference to a reference, and what happens here is that we work with a reference to a reference and we copy a reference of a reference. So this person, this variable refers to this variable, or rather this reference. And if I create a new reference, that's just a new thing that points, that this copy of reference points to. So a copy and original references still point to the same reference, which is this new object that was created. So if I pass a reference by reference, that means I can create a new reference inside the method. That is the difference. So if I print its name now, you'll see that it's John. So that's the difference. It's quite tricky. But yeah, the general recommendation is to not do that. I don't see practical point of why would you do that. Just keep it simple. Maybe there is a performance reason for this as well. I'm not sure. Or maybe you really want that somehow to potentially happen. I'm also not sure. But that's not something you would normally do. But it's nice to know nevertheless, to see the difference and what happens. Yeah, and out is quite simple. You use out quite often for the try-parse pattern. So there's nothing special. What else? Struct. Well, I gave an example of struct. There's literally nothing special about struct, except, you know, if I add read-only modifier and I don't have read-only stuff in struct, then, you know, it will complain. I can mix it, all right. That's also fine. I can have something as a getter, another thing as a read-only. It works. But structs, all structs ideally should be with this modifier, I recommend. Well, read-only properties don't work. They do. But does it work on a class? Because I swear that I've seen. Okay. I don't... Is there a point for it? Because that's new for me as well. Is there a point for it? For a read-only property in a struct? What's the difference? No. For structs, it's just quite simple. So why is this legit? Why is this valid? First of all, you will never need to write to a field a member of a struct. So the point of mixing access modifiers is not valid anymore. And then another point, data mutation. By exposing public fields in a struct, there is no problem of data mutation because those are immutable anyways. They won't change, so it's no problem. Okay, see you, Aurora. Right, I think there's one little thing that I'd like to show. Why do we need properties and not fields? One more point that I can now introduce. Let's have a person class and call it bad person. And have it have a num property. So one more point that I mentioned but never really demonstrated is the point of properties, that it gives one more benefit for data mutation, for preventing data mutation. So here is the example. Using properties. So, right. Yes, person. Yeah. Let's give one more thing to person. Where is it? Let's give it. Let's keep this get set, but let's have age. Get set. Oops. Hello, Shashi. So you said to just join the topic of the order of the struct fields come to discussion. The order of struct fields, we just discussed whether or not it should be a property or a read-only field. And either works, and it's probably more up to a person to decide. Now we're showing an example of how properties are useful for preventing data mutations in context of ref in and out. So here goes. Let's create a person. Let's say name Tom, age 50. Okay, makes sense. I'll add that to the slides. Thanks for noting that. So let's just make it identical. So if I do something like ref test and I say person good dot age, or if I do ref test, of course I need to pass by reference, person bad dot age. Do you see the difference now? If I pass a property by reference, it won't work because properties are still methods, and ref modifier requires a variable, so it won't work. And if I pass a field, which is a variable, which is data, it will work. So this is something that you would never want, and properties protect you from it. It's something that you would never want because an object should normally manage its own state. And if it doesn't, you don't really want to modify it within some method as a reference, because it will be really hard to pick up where the change to this happened. And for this, it's valid because it was a field, but it shouldn't be valid. We want to protect against that. We don't want to allow direct random data changes. So that's one more benefit for properties. All right, so now let's move on to Kahoot, if you have no more questions. All right. Let's reduce the volume. Right. So here's the pin. Let's wait for people. In the meanwhile, I'll update the section on structs to add the remark on recommendations. Biggest, the order of fields in struct should be Okay. Biggest field by memory at the top. Okay. Oh, I clicked on someone accidentally. Please rejoin. Sorry. I accidentally clicked someone. I'm sorry. Can you rejoin? Let's wait. Okay, nice. You rejoined. We can start, I think. Comment joined as well. Okay, let's go. So the first question, which of the following is not a recommendation for a struct? Which of the following is not a recommendation for a struct? No problem, blind T blind. Just double check so you know. One more person didn't select the answer. 10 seconds. All right. It should represent a single value. A struct is supposed to be like a single value. For example, a point is a single value, therefore it shouldn't be mutable. Yes. Well done. So the point about single value representation means that a phone number is just a single value. Like, you don't change a part of it, you change it, you just create a new phone number. If a phone number changes, you don't change just the country of it or just an area code. Your whole number changes. Or for example, date time. If I add extra days to a date, it's a new date altogether. It's no longer the same date. I am not modifying the same date. I'm working with a new date altogether if I'm doing addition for dates. Or for a number, if I add 5 plus 5, it's not 5 anymore, it's just 10. So it's just different thing. A value nevertheless. So all of those are recommended for struct. Structs are passed by value. Is that true or false? This one is way easier. Structs are passed by value. That's correct. Classes are passed by reference. Both are objects. When you create classes and structs, both are objects. So yeah, and therefore there might be confusion, but structs by value. It is possible to pass a value object by reference. Is it possible? And just because it's possible doesn't mean you should be doing it, but is it possible? Yeah, using ref keyword or in. Or I love catching up. What is the difference between in and ref? Yeah, so both are passed by reference, except in is like a read-only reference, so it cannot be modified. First one is absolutely wrong, and second one is also absolutely wrong. Every struct must be with read-only modifier. The keyword here was must. It should be passed with a read-only modifier. That's a recommendation, but if you don't do it, that's no biggie. It will still work, so it's fine. If you don't do it, you should be doing it, but it's fine if you don't. Like, it's not an error level of a mistake. Which of the following are not recommended implementations of a struct data? Public fields and auto properties are both correct answers, so well done for picking either. Yes. Though I would argue that auto property is worse because it's an overkill on top of a wrong solution. Okay, when should you use ref? Welcome back, Aurora. So when should you use ref? You shouldn't. You should avoid it. When should you use in? You shouldn't. When should you use out? Baited. You should use it for try parse pattern. For this one, it's actually applicable, useful, and makes sense. but that's the only logical case. When should you use a struct over a class? So the 2 points for how often it's passed are irrelevant, so both answers are correct. So as long as a data structure is small and is immutable, it does make sense to make it a struct, pretty much. When should you use a discard operator? And someone asked for links to channels. So here it is, to the playlist of previous lessons. And the answer is, yeah, out is the only use of discard operator. For those others, you don't really need it. Ref and out are completely different. Ref modifies something and passes something by reference. So I see where you're going. I guess you mean that both will persist some value, but the difference is that out out requires you to set the value, and ref just passes it. So the difference would be this. You cannot read something that is passed as out. You just assign it. That's the difference. So let's quickly make it ref versus out. So I say out not used, ref not used, do you see the difference? Private, static, void, I forgot. Do you see the difference between the two? So the first one, I just pass something by reference, so I don't really need to do anything to that thing. I just consume it. I can set it to something else and that will work, but I'm not enforced to. But for this one, it won't work unless I set it to something, and I cannot consume it. So this one is for setting and this one is for both. You should avoid in because it solves a problem of having too large structs. The whole point of structs is that they're passed by value, and working with values, with copies of values, are faster than working with something that you reference. When you use reference types, you need to do a lookup to where the reference points. And for value types, you work directly with values, so there is no lookup, not really. It's way faster. However, if you pass a fat struct by reference, that beats the purpose. It's like a class, but not really. So it just loses all the benefits. And why would I use in over out? In over ref is because it's more performant. Yeah. Than ref. Yeah. All right. So that's the difference between ref and out. Now go back to Kahoot and the winner. Hellhunter Max, Resho, and number 1, Mihail Fox. Well done. The homework. Where's the homework? On Discord. Oh, it's too big. Wait. Oh, come on. So, first part and second part. It's for those who don't. It's for those new people who just joined and didn't come from Discord. So, of course, the homework is on Discord. It's in the homework channel. If you're new, haven't joined, find it in... if you came from garbage collectors, I don't have a new branch yet, sorry. Or unless you made it just now. Because I didn't, but I can make it right now, I guess. So the homework is basically to create some sort of login, like sign in and login management system. Super insecure, super shallow, but something that would basically remind you how to use files for persistence and how to use simple data structures like structs for managing credentials. And what you'll have to do with this homework is you'll have to ask user to log in, to register if they're not registered, or log in if they're already registered. And what registering does is that it saves your password and username. Password which will be encoded. Normally passwords would be hashed, but for simplicity's sake, we'll just encode it to UTF-8. To Unicode. And then when you log in, you'll also provide your credentials. Your password will be looked up by your username, and then the encoded values will be compared. And if they match, you will be logged in. Extra parts, when you enter password, it should be hidden in the console. And you should also try to implement parsing of credentials from the file using the try parse pattern. yes, that would, so encoding in Unicode would just give character more bytes. That's not security, but I don't want to ask you to actually do security stuff because it's not the scope of this lesson. We're not learning about security yet. So I'm not asking you to do the salt and hashing and stuff like that using different stuff. It's not the time yet. So pretend that encoding is something like secure. So try parse from the file. So you read a line. So you have a single line, a string. And in that line, you should have something like this. So and you need to convert this to credentials. So that's quite simple. It's nothing special, really. But what do you mean you don't see? It's protected. Of course you don't see. It's secured. Okay. Let me commit. So let me know if you have any more questions. Lesson 2 material. Commit. Sync. Push. Done. Okay, let's push. Do you guys have any more questions? I'll create a branch right away just for the README. It'll be empty so far. I'll add the tests tomorrow evening. So chapter 3 / homework / 2. And I'll just paste what I have on Discord in the README. Okay. README. That's the one. Why do I have 2? I have no idea. Okay. Why do I have those? I also have no idea. But anyways, the README. Homework 2. What's the pattern of naming homeworks? Let's double check. Oh, also, I don't think I linked slides in the chat yet. So let's do that as well. Oh, you will have tests for a long time still. And you will always have tests. The difference is that at some point I'll stop writing them and you will be writing them instead. That's the difference. If you want to start writing them now, you're a free man. You can do that if you want. I won't stop you. Okay, the pattern for naming homework. Let's see. Yes. Chapter 3, C#, homework 2, struct in ref out. Great. I'll add more about the task, about the whole lesson tomorrow. So, homework assignment. So here's the link to the new branch. That's lesson. That's homework. Okay. I could have tests for tests, but I won't. I definitely won't. There's actually a thing called, I think it's called mutation tests. Basically, it works like this. It changes random places in your code. And if your tests are still passing, that means that your tests are bad and mutation tests will fail. Because if I change code in random places, my tests should no longer work. So if they do, the tests are wrong. So there's kind of that thing, but maybe I will, maybe I won't. It will actually be interesting to try it out. That's a good idea. We'll see. If I have time, I'll try. All right, so that's it for this lesson, guys. Thank you for watching and see you on Wednesday. Bye-bye.